Hey friends, welcome back to the next Python Pandas tips and tricks version. And this time I'm gonna give you additional tips and tricks which might help you when you work with Pandas data frames. Now I already read the data, it's the same as from the last video, and we got various columns. And the reason why I chose this data frame here is at first of course it's small, so it works quite neat on my computer, but also it contains different kinds of data types. One of the tricks I'd like to show you is how you can select specific columns based on their data type. In Pandas, there is actually a function for data frames which is called select dtypes. So I can say df.select dtypes, so dtypes, and this function only needs to have an include, and here we can specify what kind of data types we want to include in a list. A list because we can select several of them. For instance, I could say, please include everything which is numeric, then I can simply say number. And if I do this and execute this, you'll see that now I get a subset of my data with only the numerical columns, as you can see here. If you want to be even more specific, you could also say, I would like to see integer, so int, for instance. If I do that, then I'll say int 64. And then we should see all the integer values. If you would go with float, you can also say, for instance, I would like to see float values, and then you would see here the float values. So you can be more specific if you want, or number as for all numeric columns. Or you say something like float, and then as next int 64, for instance, like that, and then you can also select specific ones. Put it in a list like that. If you want to have only the text columns, the text is treated as objects. Remember that. So you can simply go in here and type in object and execute this, and then you would see only the string columns. A way to figure that out is also a good, an easy way to do this, which you should always do at the beginning, is if you say df.dtype. Dtypes, right? So then you can see what is an integer, what kind of data type it is. Actually, that's why integer didn't work for that. It's integer 64, or object here, float 64, object, and so on, right? So that's how you can see what kind of data types you have here, and then you can simply say include the specific data type. The other option would be to exclude specific data types. So for instance, you could also say I want to exclude object. So I can say exclude, and then equals object. And execute this, and then you would see only the columns in this case which are numeric. This makes sense because sometimes you have a bigger data frame and maybe you have more than just, in this case here, only numbers and objects, which we have here, but you can also have maybe date time objects, something like that, which can also be included here. Or if you would exclude all the objects and we would have specific date time columns here as well, then those will be included as well. So that's why exclude and include can be helpful. The other tip I'd like to give you is that when you're reading your data frame here, you can specify also which of the columns you want to read. This makes sense, especially if you have a large data frame, so with a lot of columns, and you don't need all of them. Then you have various options. Of course, you can call df.drop and then specify the columns. So that would be one option, right? So I can say here df.drop, and then I specify columns I'd like to drop. For instance, I want to drop the BMI column, and I specify the axis. Axis is equal to 1. And if I execute this, I would see all the other columns, and the BMI column would be dropped. If I want to save it, I either need to call df equals to this one, or I would call in place equals true. However, this of course only makes sense if you only want to delete maybe a few of the columns. But if you have a really large data frame, which maybe has 200 columns, and you only need 5 of them, then it might be easier to specify this at the beginning. So to simply say, in this case, when you read a data frame here, and then use the use calls, right? Use calls option. So I think it's calls, yes, use calls, and then you specify the columns you want to have. For instance, I want to have the age column, I want to have the sex column, and I would like to see the charges here. This, for instance. And now if you read this, you would see that you only read the specific columns, which allows you here already to make your data frame smaller, which is helpful, especially, as I said, if you have huge data sets and you don't need all of this. The last trick I'd like to show you, let me just remove this for now, and let's keep the original data frame and scroll to the bottom. The last trick is, how do I get a sample of my dataset? Now, if you're familiar with scikit-learn, you probably have used train test split in the past, but there's also another option to get a fraction of the specific data frame you have, which is actually the keyword, the fraction. Because what you can do is you can simply call a sample and specify the fraction amount you want. For instance, I could say sample1 is equal to, and I'll say df.sample. And here I can specify the fraction, so I can say frac is equal to, for instance, 0.5. And then you can also specify a random state if you want. So if you want to make this reproducible, type in a random state, and then you can execute this. And now if we take a look at, let's say, print df.shape, and also print the sample1.shape, then you would see that this is exactly half of the original data frame. So this can give us a sample. You can also have a look at the sample. So sample1. Then you would see here random, in this case random rows have been drawn from the original data frame. And if you want to reset the index, simply call dot reset index, right? Like that. And you would start with the 1 again, and maybe you want to drop it. Let's say drop is equal to true, just to get rid of this index column here. Execute this, and you would have the new subset of the data frame. The final tip I'd like to give you is, what if you would like to shuffle the data frame? This can also be done by fraction, actually. Because remember, fraction takes a fraction of the original data frame. So if we say, for instance, in this case, df2 is, or let's say df shuffle is equal to df.sample, and we say the fraction is equal to 1, which means we take the complete original data frame, but because of the sampling, we simply shuffle it. So we rearrange it, we draw randomly. And if we do this and take a look at the df shuffle, we see that now we got here completely random numbers, but we still keep our complete original data frame. So this makes sense, for instance, if you have any kind of data set and your target column, which in this case would be charges because it's a regression problem, but your target column, for instance, consists at first all of the true entries and then all of the false entries. If you have a binary classification problem, for instance, you definitely want to shuffle the data. And the sample option here would be one way to do it. So that's it for this video. Hopefully you enjoyed it. As always, thanks a lot for watching. If you have not done so far, feel free to subscribe to see more videos on that. And please comment, give me your ideas, your wishes, just let me know, and I will try my best and come up with maybe a solution for you. So that's it. Stay safe and see you in the next video. Until then, best guys.